So let's look at another example of calculating probability. So this example revolves around skydiving, and this is what's called a relative frequency probability. So here I've kind of simplified this one by kind of outlining this word problem. So given in a recent year, there were 3 million skydiving jumps and 21 resulted in death. So the question is, find the probability of dying when making a skydiving jump. So here as a guide, to calculate probability of an event, we need to use this formula. So the probability of an event is equal to the order of the event over the order of the sample space. So in order to use this formula, we need to figure out what's the sample space and what is the event composed of. To help us figure this out, we want to know, what does the Venn diagram of the event in the sample space look like? And in the end, we want to express the probability as both a value between 0 and 1, so a fractional value, and a percentage. Right? So let's start working on our visual. So I'm kind of limited by screen space, but you'll have access to the entire page here. All right, so let's look at our answer. And so let's visualize what we've got. So I'm going to draw a Venn diagram. So here's our sample space. And this is going to be composed of all jumps. And the event that we've got is going to be jump deaths. Okay, and so we've got event E is contained within the sample space of all jumps. So our sample space composed of all skydiving jumps. So that's regardless, of course, as to whether the jump resulted in the person landing safely to the ground or not landing safely to the ground. And then we've got event E, which is jumping deaths. All right. And so the order of our sample space is how many total skydiving jumps did we have? It was given here at the top. There were 3 million skydiving jumps. So the order of the sample space is 3 million. And the order of our event is, what was the number of jumping deaths that was also given? And that was 21. All right. So what we're looking for is from the question above, is we want to know probability of death when making a jump. And so probability is going to be a capital P. Probability of death, this is our event, E. And when making a jump, so that's all possible jumps, that's our sample space. So the probability of death is the probability of our event. And so the probability of our event, the probability of death, is the order of E over the order of S. So here in the numerator, we've got order of the event, which is death. It's going to be 21. And down here in the denominator, this is the order of our sample space, which is jumps. And that was 3 million. So the probability of death is going to be 21 all over 3 million. If you put that into your calculator, the straight decimal you're going to get is going to be 0.000007. So this is where the probability of an event is between 0 and 1. And if we were to convert that into a percentage, then we would move the decimal place over two spaces. And so we'd have 0.1, 2, 3 zeros and a 7%. And in terms of percentages, that does put it between 0% and 100%, just barely over 0%, but still greater than 0%. So that is a really low probability of dying in a skydiving accident. The last thing to consider whenever you calculate, probabilities is this probability that we calculated, is it valid? And so the first thing to consider is, was this a positive answer? Okay, and the answer is yes, we did end up with a positive number. And, was the probability of our event, between 0 and 1? And yes, it was. So this probability that we calculated is valid, and it's correct. And I do realize that, you could have looked at this at the very beginning, and maybe thought to yourself, well, it's just going to be 21 over 3 million. All right. I'm giving you a simple example so that you can see how to set up an example. Some of my things got shifted around. I want to deselect that. There we go. Later, when calculating probability gets a little more involved, you're going to want to use this kind of system to kind of make sense of the word problem and be able to put it together and figure it out. All right. So this does appear to be, like overkill for this type of problem. But what I'm showing you is I'm showing you my thinking, and I'm showing you the visual images that I'm having in my mind. And also showing you all the things that I'm considering when calculating probabilities, so that this will help you when calculating probabilities becomes a little more complicated.